In this demo, we'll look at the new TransformSets capability within Cast and K10, which allows you to manage a library of transforms that can be easily reused across multiple different apps in your environment. Transforms are an incredibly powerful feature within K10 that allows you to define rules for making changes to your app's metadata during a restore operation, and is critical for enabling use cases like app mobility, cloning, or, as we'll show today, disaster recovery. In my environment, I have a stateful e-commerce app, the Sock Shop, already deployed to my on-premises Kubernetes cluster. You can see I'm logged in as a user, Ted Williams, and for the sake of populating one of our databases with some meaningful data, I'll add some red socks to my cart. In my K10 dashboard for my on-prem cluster, we can see the application has been automatically discovered, including its many different services, secrets, deployments, and persistent volume claims, and that our critical data services have blueprints applied to ensure application-level data consistency during our backups. I'll quickly create a K10 backup policy, taking hourly backups and exporting them to an immutable S3 bucket to protect our backup data against ransomware attacks. And then we'll initialize our first policy run manually. Once our initial on-prem backup is complete, we can get to work configuring our DR cluster. Rather than take on significant capital expense for DR, I've chosen to use a cloud-based managed Kubernetes service. But in order to restore my applications, I'm going to have to make some changes. We call these transforms. First, we see we have a location profile configured pointing to the same S3 bucket as our on-prem cluster. Under TransformSets, I see that I have already defined one transform for updating the Kubernetes storage class that's referenced in the spec for each of my persistent volume claims. As I'm using different infrastructure for production and DR environments, it's almost guaranteed we'll have different storage classes available in each. So we can also test our transforms at this stage. Here I've pasted in the YAML of one of Sock Shop's persistent volume claims from the on-prem cluster. We can see the original storage class is prod sc csi, and once our transform is applied as part of the restore, it will be updated to ebs sc storage class, which is available on my DR cluster. What else can we use transforms for? Looking at some of the other examples provided, we can see that transforming external network settings are pretty common. This could include required changes to ingress or OpenShift route records, or it could be things like changing resource limits or config map values. Let's create an additional transform set by cloning one of our examples. Out of the box, the scale deployments transform can be used to modify the number of replicas for any of my deployments. This should be great for my DR use case, as it will allow me to scale down all of my applications to 0 pods, ensuring that all of my metadata and volume data have been replicated to my DR cluster, but with as little as a single worker node required in my cloud-hosted Kubernetes cluster. But what if disaster strikes? How would I know how many replicas I need for each deployment? Let's add another operation to our scaling transform to record the original number of replicas as an annotation. I can see that I have multiple operations to choose from, including the ability to add, remove, or replace metadata from existing artifacts in my app. For this operation, we'll want to copy the integer value of spec replicas to a string value for a new annotation that we'll call original-replicas. And of course, we want to write this annotation before we set the number of replicas to 0, so we'll have this operation occur first. Now we're ready to save our transform set and set up our application's import policy for our DR cluster. We'll create a new policy that will import our app's latest backup every hour. Because we want to be able to rapidly recover our workloads, we'll also have this policy restore our app, including all of its volume data. And here is where we'll select our reusable transform sets that will update the storage class of our PVCs, record the original number of our deployment replicas, and scale down all of our deployments to 0 pods. Last, we'll grab our migration key from the app on our on-prem cluster. This will point us to the shared S3 location profile with our backup data, and it will allow the DR cluster to decrypt that data. Again, rather than wait, we'll kick off our first import manually and can see that once the import completes, a restore begins immediately. And now that that restore is done, I can see that I currently have no pods running for any of my sock shop deployments, but my PVCs are available and using the correct storage class. And now, if disaster were to strike, I could use my tool of choice to orchestrate expanding the number of worker nodes in my DR cluster, followed by simply scaling back up my deployments. For this demo, I've created a quick script that I can pass a list of namespaces, which will return all of my deployments, as well as my original replicas annotation we created with our transform, and then scale back up the number of replicas to the desired number. Within minutes, I'm back online, and if Ted logs back into the sock shop, we see his red socks still in the cart. Looks like it's time to buy. You can find the full breakdown on transform capabilities at docs.kasten.io. And if you're ready to see the power of K10 transforms and transform sets for yourself, visit the link on screen to claim your free license of Kasten K10 today. Thanks for watching.